So now it's time to talk about the code that you're writing and how that gets broken down and processed through the computer and down into the circuit so that the CPU can run its executions. So you've written software. It needs to be transformed into a format that the computer can use. So we're going to walk through the server code all the way through the circuits. And where does that start? So a person sits down at their computer and they open up their browser and they're going to put in a URL for a web page request. And this is going to travel through the internet, and we're going to cover this whole communication side in the next course and how this all travels through, how name servers work, and all of that we're going to cover in the next course. The web server that's sitting on a host somewhere out there in the internet, it's on the server side, receives this request. And now it knows what to do with it. So this is a piece of software that's sitting on a physical piece of hardware, which is a server. How does this software run? Does it run from the hard drive? Shake your head, no. No, it does not. It runs from memory. So it's been loaded into memory. The web server is spun up and it's sitting there and it's waiting for a request. Once it receives that request, now it's going to be able to spring into action. It knows what to do at that point. It says, I need to go and load these assets. So I'm going to go down to the hard drive and I'm going to say, I need the script files to be able to load up the programs that are being requested here. So I have my WordPress core that needs to be loaded up. Those scripts need to be loaded. I also need to be able to load in what? The PHP that you've written for plugins. I need to be able to load that in. I need to be able to then go and load up the themes as well. So all of that code needs to be loaded in. And what's going to happen is, can that code then be instantly put into memory and run by the CPU? No, it cannot. Right. It needs to be converted. So it's going to go through the PHP interpreter. So the interpreter's job is to then take your code and parse it. So it's going to go in, it's going to check the syntax for you, and then it's going to convert it into bytecode. What does the CPU need to be able to run each of the instructions? We saw this in the last course. What does it need? It needs ones and zeros, right? And our code is sitting there in what format? It's in human readable. Okay. So I need to convert that over. And that's what this interpreter is doing. Now, if you are working in an ASP web server, you would be running code that's compiled. And that compiled code has a different process. So instead of at runtime having the conversion occur, it's actually going to occur when you get done writing your code. So you write your code and then you compile it, and now you have it in a format that can then be processed. All right, so here we're dealing with a conversion process. We're getting it into the ones and zeros, and we load that machine code into memory so that it's ready to be processed. Now, some of that also needs to come from a database, so we're going to load that in as well. So now I have all my data sitting there. I have my instructions. I know what to do. And if you remember from the last course, the CPU, or the engine or brain of the computer, needs very small incremental instructions. Load this. Load that into memory. Then you're going to add. Then you're going to take that result and you're going to put it back into memory. So that's what the machine code is. It's broken it down all the way down into those instructions and data that need to be processed that are now going to run through the engine or the brain, which is your CPU, by the way. Those instructions get processed and the data is put back into memory. And then we complete the cycle. So once it's all done and it's built it back up, then we can pull the rest of the resources from the hard drive, which is going to be your HTML, your CSS, your JavaScript, and all that's going to be sent back through the internet back to someone's computer, wherever they happen to be in the world. All right, so this is how your code is going to be processed to get it down to the CPU, down into the circuits. Let's start with what a computer is. What's a computer? I know that seems like a silly question, doesn't it? But you might not always think about a computer in the context of what it actually is. So let's go through that. First, we're going to look at two different definitions. So the first one is it's an electronic machine that can store and work with large amounts of information. Now, there are key attributes in this, and we're going to break those down here in just a moment. So here's another definition. An electronic device. Notice that both of them say electronic. One's a machine, one's a device. For storing, notice they both say store, and processing data. They both have processing or work, typically in binary form. Yes, we know that. According to the instructions given to it in a variable program. So I have data, I have large amounts of information. That's the same thing. And then this one's a little bit more clear on what it actually does. So it's taking instructions from a program. Let's break down those key attributes, what we just talked about. Do you remember them? See if you can list them out. One by one, list them out. Let's go. The first one is what? It's electronic. We're going to talk about that. What does that mean? Next, it's a machine or a device. It's a mechanical machine. Okay, you're going to hear me say that a lot. A mechanical machine. That's all a computer is. It's not, even though you may think it's very intelligent, it's not an intelligent piece of equipment. It's extremely efficient. The software that runs it is where all that information comes from. So it needs to be able to store information, and it needs to be able to do what? It processes, executes, and works on that information. And it's in binary. Those are your key attributes. There's one more though. What is that? What do you think's missing there? It works per the instructions from software. So we have the computer is a mechanical piece of machinery, and we write the software, although there is also other software, right? There's the operating system, there's interpreters, there's compilers, there's even some other software sitting there that takes that and breaks that down too. So what does it need? What's a computer need? So let's look at the attributes again, and then we're going to specify the needs. All right, so we know that it's one of the attributes is electronic, right? So it needs electricity. It's a machine. It's mechanical. It stores information. It needs retention circuits. Okay. And we're going to get to that later in this course. What are these retention circuits? How are we storing this information? It needs to be able to do what? It runs processes, it executes, and it works. So it's got an engine or a brain, and that's our CPU. It needs binary. One of the attribute is binary. That means digital circuits. Okay? Digital circuits. And it's going to do its processes per the instructions that it receives from what? Come on. What? Software. That's right. So we go through this. We see we need electricity. It's a mechanical machine, so we need the mechanical machine. It needs retention circuits, electronic circuits. It needs an engine or a brain. It's got to be able to do the computing. It's got to be able to handle the instructions. It needs digital circuitry, and it needs software. So let me give you some examples. Of course, your desktop or laptop. And of course, any of your mobile devices. And a server. How about your car? Your car's got a computer in it. Actually has a couple of computers in it. How about an automatic teller machine, an ATM? you go up to the bank, wherever you happen to be, and you interface with this machine that you're able to check your balance. You can do deposits, but you can also withdraw cash. What's your digital alarm clock? Yeah, it's got circuits on it. It can do some of these things. It's an embedded process. Even your microwave oven has an embedded little computer in it. So that's why I say understanding what a computer is. There are all different types. Our software and what we do is not just related to just the servers and web pages. It's much more, and it's all around us. Let's take a look at the anatomy of a computer. Okay, so we have this external case. We know it's a computer, right? We know it has some sort of engine or brain. What else does it need? Think about it a minute. What else does it need? It needs memory storage, right? We said it needs a way to retain information. So it needs memory storage. And memory storage comes in a few different ways. We'll talk about those. But you have your hard drive, your RAM. There's multiple different ways to be able to handle memory. And it depends upon if you want long-term, short-term, or working. It needs to be able to take external information in, right? So you need your keyboard, maybe your mouse. As I'm talking here into this microphone, that's external information that's coming in within an audio format. There's video being fed in right now as I'm recording this. Depending upon the types of machines that you work on, there may be some other instrumentation that gets fed in. So let's say, for example, that you're working on a web server process. There could be temperature being fed in and you want to read that. What else does it need? Well, of course, it needs software. This is what we do all day. We write software. And it's digital. Digital. You might not understand the circuit just yet, what that little schematic is. Those little square waves. What does that mean? We're going to go into that a little bit later. But it's digital. And of course, it needs power. If it's digital, it's a machine. If it's unplugged, it's not going to work. So it needs electricity. So let's do our takeaways here. What are our takeaways? Instructions and code are software. That's what we work in. Software is converted from the human readable format to the ones and zeros that the computer circuits need. Okay. So think about that. Human readable format. We sit there and we define what a variable is, what a function is, what a class is. We just write that arbitrarily. We give it a name. Doesn't matter what language you're working in. I could be working in Ruby. I could be working in PHP. I could be working in a .NET. I could be working in JavaScript or Java. But I give it a human readable format. And then that's broken down into the ones and zeros, down to what the circuits need. We went through and we gave you a definition and the types of computers to open up your mind, to see big picture that a computer is not just what you're watching this video on and listening to me on. We went through the key attributes of what a computer is. So what defines a computer? What are those key attributes? And we saw a big picture view of the computer anatomy.